Hello students, this is Dr. Sourav sir's class. We are solving our National Boards of Higher Mathematics questions. This question came in our PhD entrance test from the year 2022. So the question asks us that let our A be an invertible 3 cross 3 real matrix such that A and A square have the same characteristic polynomial. Okay, so A and A square have the same characteristic polynomial. That means the roots of the characteristic polynomial will also be same. So the eigenvalues are same. We can say that. So what are the possible traces of the matrix A? I think this is very easy question. Yeah. So let our date of A not equals to 0. So then or our date A is what? We know that this is the product of all eigenvalues. So let our each eigenvalue, now as it is an our invertible matrix, so that will be non-singular, so this thing will happen. So the each eigenvalue is my non-zero. So what can be so lambda 1, lambda 2 and lambda 3 be the eigenvalues of A and A square also. Yeah. Because they share the same characteristic polynomial. So the roots will be also same. So we know that the roots of the characteristic polynomials are the eigenvalues. So the eigenvalues of A and A square are same. So we can only name these three. Now our if lambda is an eigenvalue of A, let me write it in another color. So if lambda is eigenvalue of A, then our lambda square will be eigenvalue of A square. We know that, no? So then what will happen? So our lambda 1 will be lambda 1 square, and our lambda 2 will be lambda 2 square, and our third case is lambda 3 will be now lambda 3 square. Then what are the favorable cases? What are the possible cases? So our lambda 1 square minus lambda 1 will be 0. Then we will get lambda 1 common, lambda 1 minus 1, that will be 0. So our lambda 1 will be my 0 and 1. For this case also we will get this thing. So again the possibilities of lambda 2 are this, and also the lambda 3's possibilities are also 0 and 1. As we know that the matrix is invertible one. We know that our matrix is the invertible one. So we only take these values, these eigenvalues, because the eigenvalues can never be 0. So the trace of A is what? Trace of A is, we know that the summation of all eigenvalues, here I is running from 1 to 3. So that is my lambda 1 plus lambda 2 plus lambda 3 will be what? That will be 1 plus 1 plus 1. So that will be 3. Hope you understood. Thank you guys.